Hello everyone, can you hear me? Hello? Okay, let me introduce myself. My name is Amir Ahmed. I'm an Egyptian architect, computational designer, and co-founder of Exact Architecture Studio. We are based in Egypt, in Al Fayoum city. Uh, Let me start sharing my screen. Can you see it? Hello? Okay, let me go with the talk today. I will talk today about the Morpheus Hotel, originally designed by Zaha Hadid architects. I only going to talk about the envelope from the geometrical perspective. I did the envelope in a computational way in a Grasshopper using sub-D advantages. I will explain what I did when I go to the Rhino, but first let me say what I'm talking about. Can you see my screen? Hello? Okay, perfect. I'm sorry, this is my first online talk and I seem to have a little bit of technical issues, but I hope it goes well. But thanks everyone. Okay, let's proceed. These are the topics that I will talk about today. I will break down the envelope complexity. I will create and control a data tree. Of course, I will not create everything from scratch because it will take so much time. I will only create, as you know, show what's inside the clusters, which you already seen if you saw my post on social media like Instagram and Facebook. So many people asked me how you did it, so I arranged this talk to explain what I did, but of course I can't build it from scratch in such a small webinar. It will be around 2 hours. I hope to cover everything about the full envelope. I will create a little bit of custom components, or what they are called clusters in Grasshopper. I will show why they are important. I will create a non-linear grid which creates basically the structure and the envelope. I will share a lot of Grasshopper tips and tricks, and let's start a little bit with an introduction about us. We are Exact Architecture Studio. We are established in Egypt in July 2020. We are design, visualize, detail, fabricate, and build. These are some of the work we did. Some of them are in Saudi Arabia, some of them are here in Egypt. We combine computational skills with architecture and interior design, and we hope to grow as a business and as an architects. We also collaborated with some other architects to do some specific computational scripts, and also in the design stage. These are some of the interiors that we did recently, and this project we worked only on the facades design, and also some of the fabrication sheets. I'm just moving fast here so we can keep tracking with the time. Also, this one is we designed this in Saudi Arabia. It's 3 cafes connected together. This one is still in the design stage. It's a conceptual design for a mosque. It combines so many computational aspects. These are some of the shots. It's only the first sketch yet. We still developing it. Recently, for the last like 5 or 6 years, I developed an interest in the computational or parametric geometries. These are some of the geometries that I just did for fun or for research or for studying during college or something like that. This one right here on the left is was my graduation project. It was a vertical sustainable city. Of course, you can see that I developed so much interest in the geometry. I have a lot of techniques. Sometimes I try different things. I had an interest in the fluidity, as you can see in this one. This one is from Zaha Hadid Architects. I was interested in the towers, how they are developed, how they are developed the concept, and I took the concept and I created with my own vision. These are also by Zaha Hadid Architects. I created my own version. I developed a lot of practicing skills, computational skills, because I wanted to create. When you design something architectural and you want to push it further, you don't want anything to stop you from the technicals, from the design, from the geometry. So you need to practice more and more. That's why I kept practicing and practicing until this one is the recent one I did with Engineering as a participant for the workshop. It's sub D. It's a tower, and as you can see, it's more complex, and also sub D with Grasshopper. That's the newest thing I have dealt with. Now let's talk about the Morpheus. Enough about me and enough about our business. The Morpheus Hotel is originally designed by Zaha Hadid Architects. Let's say I will talk about the Morpheus only from the geometrical perspective. After all, I'm only an architect and computational designer. I'm not a structural engineer. I'm not a facade consultant. Let's say I'm just a young engineer and trying to learn and trying to develop myself constantly, and this is where I've got so far. I developed an interest in this building because, as you can see here, it's the world's first high-rising building supported by a free-form exoskeleton steel structure. It's really complex, but at the same time it's really unique. The structure is holding the exoskeleton itself is holding the facade, and it's really amazing if you are an architect and you can handle such a complexity, especially if you are a computational designer. uh, there is a lot of the information. Of course, I can't say everything about the building in one talk, but of course there is a link in the description called important links. Contains a lot of videos, webinars, lectures about the building, about the construction, about the detail, about the design, from of course from Zaha Hadid, where they are the main designer and the concept designer of this project. Bro Hubble was responsible for the structure and the exoskeleton, and also Front was responsible for the cladding and fabrication of the cladding for the exoskeleton. And of course they developed such an amazing thing. As you can see here, these schemes, or these let's say forms, are fluid, are amazing, are looking amazing, but when you want to make something architectural from them, it's kind of hard, because as you can see here, this project developed from concept design. As you can see, it's kind of a fancy, nothing engineered, nothing rationalized. But of course, when you look at the final design, you can see that it's more rationalized. It's able to be constructed. As you can see, this is the structure. I only worked on the exoskeleton, which you will see. This is the original one, by the original structure by Bro Hubble. As you can see, and as I mentioned, Zaha Hadid and Bro Hubble and Front, they are worked together to make everything fit together. Zaha Hadid worked on of course on the main design, and they put the general layout of the exoskeleton, and also they designed the cladding and rationalized the nodes. Bro Hubble worked on the structure and the nodes. Front worked on the technical details of the cladding. You can see in this picture, as you can see in here, the building itself, the exoskeleton itself, is more complex to be done in a modeling way. You can't model every part yourself, because that will take you like forever. You need to work on each. You need to work on multiple elements in a computational way, in a parametric way, because you want to find the rules that controls everything as much as possible, to save yourself sometimes. And that's what happens. You can see that in this case the node is simple, but if the angles are narrow, you can see that you have here a smaller node contains sub nodes like this in the structure, which joins the member together. The nodes itself, the nodes design, are different from multiple places in the from multiple places on the exoskeleton. You can see also that the structure itself, the members are sometimes rectangular or square, sometimes is circular, sometimes there is an edge or an I-beam, something like that. There is a lot of complexity and a lot of difficulty. These are some of the claddings that they did, the node claddings, and as you can see, you need to make sure that everything is rationalized. These are the flat surfaces, these are the single curved surfaces, these are the ruled surfaces. You need to understand what you are dealing with, because you need to rationalize, you need to make a technical drawings. After that, you need to fabricate those hard geometry. And also to understand the complexity more, when you have a structure like this, this is the main building, the curvature of the building, and this is the structure. If you have the structure simple and the envelope is simple also, you will find out the structure, okay, the structure will fit, but the envelope will make a weird intersections, and as you can see in here. If you did it the other way around, you did it you did the structure and the envelope to follow the topology of the envelope, you can see that it develops more complex geometry as a structure, which is almost difficult to be calculated and also not rationalized. So they came up with this idea, which is, as you can see here, you can fit a simple structure, and you can see the cladding is more respecting to the envelope, so everything will work, everything will be rationalized, the final product will be more beautiful, more aesthetic, and also the structure is simple. That's why you need to understand the logics here. As you can see, you must deal with Zaha Hadid. Zaha Hadid is doing a full size mockup. As you can see, this is the part of the building, the part of the actual envelope that approved of course by the client. I don't think most of the companies are doing like this, because only Zaha Hadid can do it, or maybe there are other companies, I don't know about them, but imagine how complex this is to convince the client that you can be able to achieve such a complexity. This is just to imagine how much difficult how much complex the envelope is, and how much the technical drawing is. These are some of the technical modeling that have been done by Front. These are some of the cladding fabrications. As you can see, because some of the cladding sheets are not flat, they are kind of a batched surfaces, you need to kind of make this grid, and this grid actually they are not flat from the top, and actually after that you need to push the batch surface that you cutted, push it down and weld it to it, so you can fit it on the structural node. And as you can see, these are some of the final and ready cladding nodes. So to conclude everything here, you can see that the cladding and the structure and everything is fit together, but there is almost like every piece is unique, and you need to make sure that there is a system that follows the design to make everything combined together and fit together, and easy to read by the manufacturer and also by the contractor at the site. These are some of the complexity that you can imagine what's happening. These are some of the original Grasshopper that they were dealing with. You can imagine how complex they were. And these are some of the facts about the building. You can imagine how much cladding area, how much panel counts, and most of them are unique, as I said. Connection to primary structure, panels, stiffeners. You can see that some of them are with millions, and that's almost a nightmare for the contractors. So you need to find a way to solve everything. This is my humble example, my humble exercise that I did. this is my humble exercise that I did for this building. This is my humble exercise that I did for this building, and as you can see, it's not 100% like the original building, but this is my own you know, let's say, attempt to develop such a complex thing. As you can see here, I did at the first I did the Nurbs, because when I started to work on this design, it was the early stages of the sub D with Rhino, so there wasn't available tutorials a lot. So I did this one with poly surfaces, and after that I turned them into sub D with Grasshopper, and after that I worked through all of these processes to get the final envelope. I've done the glazing, the exoskeleton, the cladding. You can see that there is a lot of clusters here, just to make everything organized and easy to read, easy to reach, easy to work on, because with a huge project like this, you need to be able to reach the part that you need to edit easily. These are, as you can see, some of the structures and the cladding as a symbol. As you can see, the cladding and the cladding in here and the structure are rationalized somehow. You can see that in case I need some complex node, I created some complex node. In case I need only a simple node, I created a simple node. The cladding is fit around everything, the members, the nodes, and this is actually they did a similar approach to this. You can select a specific member of the structure, and you can select the same specific cladding member, and you can measure the distance between them to know if the technical drawings, if the technical elements will fit inside or not. That's really important to manage, especially in the design stage. Okay, you need more space here, you need more space there. Of course, I did this just to as a practice. I didn't go through the actual space, how much do I need, but this just to imagine how they could do such a thing. You can make a frame and make it move around. Of course, I will show most of these in the Grasshopper in a moment, but for now let me just show what I did in conclusion. These are if I picked one member cladding and I wanted to fabricate it. This is the original member, and I deconstructed it or maybe explode it and give everything a parametric code, and after that I unrolled the surfaces to make sure that everything is flat and easy to cut. That's for the cladding members. For the nodes, for the cladding nodes, I did maybe a similar thing, but as you can see, these are ruled surfaces, so they will be easy to be fabricated like this. But these are batched surfaces, so they are not planar surfaces. They are double curved, and you need to make sure to make a mold like this to push them above it and to weld them. So that's what I did. This is a closer look to them, and these are some of the coding, parametric coding and openness and stuff like that. Now let's move on to the Grasshopper and Rhino. Let's see what's going on. If there is any questions, I think we are good to go. Actually, there is. Will the video will be available on YouTube? Yes, the video will be available on YouTube after this. Okay, let's move on. Let me explain a little things. Of course, this is the f- the full script that we will working on, but of course I can't go through everything from scratch, so I will open the clusters, show what's inside, why this working like this, and we can move on to the next stage. But before I did this, I will show a little bit of I will show a little bit of ideas that helps to make such a thing. Let me show you this. Okay, let me say I want to create a grid or on this surface. I want to create like this. This is the main surface. I want to create line from here to here to here to here, and again down here. So if I want to create it parametrically related to the surface, I want to evaluate the surface, and after evaluation, let me draw it again. Sorry about that. Okay, so if I evaluated the surface, uh, this will be the U, uh, this will be the U, and this will be the V direction. It's like an X and Y, but related to the surface. So if I said, okay, show me this point, as you can see, it's here. This point is 0 and 0.5. It's in the 0 direction, and 0.5. This point is this point is 0.5 and 1. And as you can see, I did the same thing preview on. I created the 4 points that I needed. I created a curves related to them, and that's the grid that I wanted to create. But of course, in a case like this, it's easy. But when you deal with something like this, let's zoom. Actually, if you want to zoom to a specific component, or to a specific item, you can just click on it and right click on the canvas and click zoom, and you will go right to it like this, and it's easier to maneuver around it, and to see what's going on with this item or with this tree or something like that. This is a great trick for this. If I need to add a little space, of course you know this one, most of you will know this one. You click alt and you push, but if you release the alt and click it again, you will split the canvas vertically. That's one of the greatest tricks. Actually, if you want to create a component, you will have a lot of components here, and if you want to search for a component, sorry, and you will have a lot of components here, and it's more difficult to memorize their shortcuts. So I developed a way to find a component easier. You will type the first 2 letters from each word. For instance, let's say list item, I will say LIIT. I will find it easily. If I said list length, LILE, I will find it easily. If I said, for instance, param subdivide, BASU, param subdivide surface, it's kind of a fast way to type the names of the components and get them easily. You don't have to type the full name. It's kind of a quick way. If the component is one word, maybe you can type like polyline. If I said let's say BLI, I will find it easily. There is tree trim, I use it a lot, but if I said TR, I can't find it because I have so many components. But there is a shortcut for that. It's trim. and you will find it so easy. There's a lot of things like that, but mostly the two-letter way is really great. If I said, for instance, divide domain, you will find it so easily. It's really a quick way to help when you are working and you need to move fast. Let's say, yes, if I want to search for a specific component, let's say I said param subdivide, okay, and I want to know what are the other options that help me do something like that. So I will say Control Alt, and I will click the left mouse button. It will show me where's the component is, and in this way I will find it. Let's click again. You can see that there is a lot of components related to the surfaces, and maybe one of them will be helpful for me. For instance, if I want to create a plane, and there's, for instance, there is a 3-point plane, and I want to know what are my other options. I will say, okay, let's say this, Control Alt and click on it, and you will see that in here you will have another options. Maybe one of them will be perfect for you. That's really a great trick. Now let's move on. This is the simple way if the surface is planar, and it's not it's kind of a rectangular or a square or something like that, and you want to create something, a grid like this. But if the surface, as you can see here, let's move on to this, zoom, actually not this, yes, let me explain this one more time. Yes, I created this again, but instead of creating it preview on, and instead of creating it with this idea, with the MD slider, because it's not perfect to control, and you need to make a complex idea. So the point oriented is a great component, because you can move on the surface, and at the same time you can, let me show you what's going on. Yes, you can see it in here, and at the same time you are related to the surface 100%. So they were perfect in a planar surface. But if you want to work, preview on and zoom, if you want to work on a surface like this, it's more curved, it's more complex. This concept will not be perfect, because after all they are lines and they are not following the surface. So I created another way, but instead of let me show you the final result here. Instead of making a simple line, it will be an interpolated curve following the surface. How I did that? Let me show you. You can see here. Let me say the display and make the plan view a little bit bigger. Let's say 1. Okay, maybe 2. Yes. You can see that I created multiple frames. I created first thing I created a range between 0 to 1, and that range I created I remapped it once from 0 to 0.5, and another one to from 0.5 to 1. This is the points that I used. Of course, when you are working on one surface, you can create as much points as you need to make the curves exactly following the surface. But of course, when you are working on multiple surfaces at the same time, you need to make sure that your script is running smoothly. You don't want to overdo raise the number. Maybe you can just make it like 10 or 20, whatever it feels great, and also not creating a hard time for your PC to calculate everything. So for now let's make it 10, and 10 works perfectly because you can see that the curve is in the surface. Let me hide this, preview off. As you can see in the U, it's from 0 to 0.5, it's from 0.5 to 1. Why I did this? Let me show you. I did this because I wanted, let me show you, for instance, in here. I will explain what's happening before, but for this I will show you. Let me zoom in here. Yes, and let me show you the surfaces. You can see that in each surface I wanted to create a specific grid, and I wanted to create this. In this case there is a lot of layers and a lot of surfaces, and you want your cluster to be as much lighter as it possible. So these are the surfaces, these are the final curves. So that's what we needed to create this. Again, let's zoom, so we will go back to the surface that we are working on. So now this one is from 0 to 0.5, this one is from 0.5 to 1, and you created this curve. Again, I created the 4 curves, and everything is working perfectly. For some reasons, this preview on. For some reasons, I have to. This is the vertical, and this is the horizontal and vertical curve. Some reasons, the evaluation of the surface is not perfect in all. Is not perfect in all of the surfaces. So I created a way to avoid that by projecting the start point and the end point of each curve, or for this one and this one. So these are the projection of the points, and I told him, okay, measure the distance between the start and the point and pick only this is the sort point, to pick only, as you can see in here, the distances are 0 and 40 something. I told him, okay, pick only the lowest member. So the vertical lines only, if you picked the vertical lines and you projected them, they almost project as a point, or sometimes if the surface is a little bit slanted, they will be shortest than the horizontal curves. So when I pick only the first one, usually the sorting, as to understand this component, is picking from the smallest to highest. That's why you need to understand this point. So if I said, okay, pick only the smallest value, or the first value, which is the smallest value in this case, he will only pick the vertical. That's why I did it this way. And now let's see what's happening in here. Let's go back to our script and start dealing with everything. Okay, let's hide this for now. Okay, I exploded this to understand, to make you sure that you understand what's happening. In this case, I have the poly surfaces. Let me show you the main. Let me show you the original surface. Let's select, right click on the layer on Rhino, and say select objects, and you will select everything in this layer, and say okay, zoom selected. It will take a little bit of time. Yes, hello Ivan. I did use the curve on surface, but it got me a weird. Let me show you. Let me show you real quick. Zoom. Okay, let's say extract parameter. Yes, because I want this surface here, and okay, input this one here. So let's preview on and zoom. So as you can see, as you can see here, the curves, these curves are not on the surface, most of them at least. So if I set curve on surface, yes, these are yes, this is the surface. Actually not, no, you meant project. These are the curve, sorry, these are the curves, these are the periods. Let's say graphed. Well, it doesn't work. Anyway, this let's say curve on surface. These are the curves, these are the surfaces. As you can see, they are not working. So that's not what we wanted. But for now, this one working pretty well, because it's related to the surface, and I don't need I only need the curve to follow the surface. I don't need 100% curve following the surface, but in this case it's working pretty fine, because after all the sub D surfaces are not super complex. After all, most of them are quads, and quads are perfect to work with them in this way. And also one of the things that I wanted to work with, that I wanted to minimize the processing time of the file as much as possible. So I wanted to use a simple components that Grasshopper will be easy to work with them, easy to process them, and it will be a faster way to process. I did this project like multiple times. For most of them, it was like 8 minutes or more to process the full project, but the final the one that I'm showing you today, it's like less than 200 seconds, almost like 3 minutes and some change. So it's important also to try to process your work faster, try to make sure that everything is going so fast, so everything, you know, easy to work, especially if your workstation or your computer is low with the specifications. But in my case, my computer is just fine, but I wanted to make sure that it's not exhausting. Okay, let's move on for the next part, which is, let's preview off everything in here, and now let's go back in here and zoom. You can see that this is the Nurbs that I did. Let's say yes, let's go back in here and select objects, and again zoom. Yes, I did it. I did this poly surface, and as you can see, most of them are separated, and I will show you why in a second. But this one is the most complex one, but it's all joined together. This one, this one, this one. And I wanted to convert this thing from Nurbs or from poly surface to sub D, and that's what I did. Let me show you. This is the, let me zoom a little bit in here. Okay, this is the Nurbs, the poly surface. I exploded it, I transfer it into a simple mesh, I joined everything together. As you can see, it's important to understand your data tree. In here, it's one branch with 39 let's say items or poly surfaces. After I did this, again, as you can see in here, it's way much more. I don't need that. I need it to be simple, because let's see what's happening in here. Yes, it's coming back to 39 items, and this component called, let me go to bifocals. Sorry, it's here. Yes, this component called mesh direction. Mesh direction is important to make sure that your mesh is perfect from the orientation, because when you want to offset the mesh, you need to some of the meshes are offsetted to toward the inside, some of the meshes are offsetted toward the outside, and this is not really helpful. So mesh direction is kind of making everything inside or outside. So that's really an important component. I wanted to offset the mesh. Let's say, let me show you what's going on in here. This is the glazing. This is the layer of the glazing that I've did. After that, I did the structure, and after I did the structure, the layer of the structure, I did 2 layers for the cladding and 2 layers for the cladding. Let's say again, this is the 0, this is the 1. Sorry. Okay, this is the 1, this is 2 and 3, this is 4 and 5. So after that, so this is the glazing part, this is the structure, this is the first, this is the second, and after that 3, 4, 5, 6. It's easier to work with them that way. So again, let me show you the sub D layers to understand what's going on. I created a custom component for that. Let me double click. When I will show you how to create a custom component, but for now let me show you what's inside, and I will go back. This is the sub D layers. I will explain what's happening in here, but for now let me tell you what's going on. Let me show you. I created a clipping planes just for this. Select object, yes, and hello. Again, select objects. I want to select this one, go in here, and okay, work on the perspective. Okay, let me see what's going on in here. Let me zoom, select this one and zoom. Okay, this is the first layer. This is the first layer, which is the glazing, and this is the second layer, which is the structure. And these two and these two are the cladding layers that I will work on for later. You need to understand that the layers of the data are important, because as you saw before. Let me go back in here, and let me share this one again. Sorry, let me share a specific slide. Yes, maybe this one, and Yes, as you can see here, let me maybe zoom a little bit. There is a chamfer, and there is no such a thing in there is no such a chamfering in the Grasshopper, so you need to chamfer it manually, but not manually in a let's say you want to chamfer it parametrically. You want to get this nice chamfering feeling, and you want to create a simple structure. So you want to create a 4 layers. I created the 2 layers in the front and the 2 layers of the back to create a nice chamfering to the cladding. That's really important to understand. And now let's go back in here. Let's say yes, Maher, the video will be available after this session. Also, Ivan, yes, thank you. You can actually DM me or DM Exact. You can find the links in the description for our social media. Okay, let me show you how to create. Now I created this. Let me show you now. I created, of course, I created let's say let's say a layers of a layers to transform them into sub D. I made sure that they are not solids. I want them just as layers, as a simple mesh. After that, I turned them into sub D, but there is an important trick in here. Let me hide this. You need to understand that the corners, I want them at the mesh. If I said none, you can see that there is a weird well, it's not weird, but sometimes it's useful. There is no corners at around your shape, but in this case I wanted, okay, give me the corners around the at the mesh corner. Give me a corners. And now if I came here and okay, insert this one here, you can see that there is a lot of sub Ds, and I don't want that. I want it to be, as you can see in here, there is 6 layers of sub D, and I want the same 6 layers because I want to work on each layer separately. So now I have this is called tree trim. The shortcut for it is trim, and you will find it so easily. This is the depth. You can cut one or two or three paths. I will show it more in when we go further. And as you can see, this is how you transform basically a PRIP into sub D through meshes. So that's what we need to deal with. Now let's say that I want to create a every time I want to work with sub D, I want to create a Nurbs to sub D. I don't want to create this from scratch again and again and again. Of course, when you will do the same process, you will do exactly the same process. So there's something called clusters. Clusters has an inputs and outputs. You can find them in here. The white one is the cluster output, the cluster inputs, or you can just go right here and click cluster. But there is something really important you need to understand. If there is no wires coming out of here, or there is no this component is not available, there will be there will be no output. Let me show it again. You can cluster like this, and you will find that there is no output available. And I want the output to be available like this. Okay, and cluster. Now my clusters will be the input is PRIP, and the numbers, and the output will be sub D, and that's really important. If I want to create, of course this cluster is available for this Grasshopper file. If I want it to be available for every file I will work on, there I can save it as a component. In here you can see that I saved some of the clusters. Let me show you how. I will click on it, I will go to file, I will go to let's say create user object, and let's say this cluster will be named like brep to brep to subd. Okay, of course you can make a nickname for it, but for now I don't need to do that. This is the description if you want to make a full description about this. This is actually the category. You have all of the categories here, and if you want to put it in a different, let's say if you want to put it with the subd or another thing, you can do it. But for now I want to create my own let's say library of components, of custom components, of clusters, and I want to use them, and it will be easy to find them. Again, let's say of course I don't want to change this. This is the name of the branch right here, the subcategory. This one is data tree. I created this one to be custom subd, so this will contain the customized clusters for subd, let's say. And these are the icons. I can check another color. Let's say for this one I will say okay, give me this red one. This one will show you a lot of the icons inside the file, but of course it's heavy, so I will not open it. You can try it yourself. This one will browse your file if you have a specific icon you want to put on your cluster. And now if I said okay, I will see my cluster up here. And if I go to special folder and I go to file user object, and again I say okay, brep, I will find it here, brep to subd. This is my cluster. If I copy it and okay, let's go to desktop for instance, and maybe create a new folder and save it for later. Okay, this will be the folder for your components. You can every time paste them, and every time you download or install Rhino, you can paste them in the file, and in the user object file, and it will be easier to use them again and again, and easy to share them with your friends and stuff like that. Of course there is a lot with clusters. Maybe I can share one trick or two with clusters. Now let's say I deleted this and I said brep to subd su. I will find it right here as a component, and I will use it, and it will be perfect. Nothing is weird right here. Amazing thing that I can edit it. For some reasons I can edit it. Let's say for some reasons I will remove this one. I will make this one right here. Okay, and I will say brep su brep to subd, and if I clicked right here, this one is having this item, so it will not disturb the original one. And also you can edit on it. You can make a password if you don't want to mess with it and you want to share it, but you can use it, but you don't want to mess with it. You can explode it, but there's a trick here. If I said explode, it will push my script forward. So sometimes it's easier to explode somewhere in the after everything else, and bring it back. So if I said explode this cluster and worked with it, or maybe I need to edit it and make another cluster, it will be easier. If I want to edit something right here, you can click on here and save the cluster, or you can discard and close one of them, as much you can work with any one of them. Mostly for this session, I will not save anything, because as I mentioned before, it will take like 200 seconds to process, and if I repeat this process again and again and again, save and save and save, it will take like so many times, so many unnecessary times. So that's it for the clusters, and that's it for this part. I don't need it anymore. Now this is the sub-D part that I did. Let me show you something really important. This is an item called split tree. Split tree, when you have, let me show you the tree of the tree in here, how it's look like. The tree in here is 0 1 and 0 2 0 4, and when you move on, you can see that this one is 5 3 8. To understand what's going on, there's a main 6 layers which we already did when we offsetted, and a lot of let's say sub branches inside it. So I don't want to deal with them. I want to split, let's say 0 with the sub branches all at the same time. So if I said okay, show me this, you can say that in this case I split it the 0 1 0 2 0 3 whatever it is until 0 3 8 38, and this is a custom component I created. There's a component in here called construct path. Construct path is great to create paths. Let me show you what's going on. If I said 0, let's say for instance if I said 5, okay, I will say that I created a tree branch called 5. If I said okay, let me Control C, Control V, I input this here, you can see that it's 5 5. If I said okay, graph these, you can say that I created 2 5s. This is an amazing component, but unfortunately I didn't I wanted to split the tree, and I want to keep the branch 0, which is the main branch, and I want to keep everything else the same way. So in this case, if I took this in here and I said okay, bring me those and those, you can see that it's not working. The star is not working, so I had to create a custom path. This one is the bracket, the number, the comma, the semi-comma, and the number again. So discard and close. If I came back in here, you can see that the input in here is exactly what I need as a branch. So when I say okay, split the branch in here, you can see that I split it only the 0 and all the sub layers that is available, and you can see here, let me preview this off for a moment. Preview off. This is the 0. Okay, I did it again. Split list give you let me show you again. The split list give you the positive and the negative. The negative are the other layers that you didn't wanted to deal with them. Sometimes you want the negative layers, sometimes you want the positive layers, the positive trees and the negative trees. In this case, you can see in here there is 1 and 0 because I splitted only the 1. and in this case, if you saw in here, you can see that 5, 4, 3, 2, these are the negatives. I splitted them back to become 0, 1, 2, 3, and this is a great component called tree branch. Let me show you what's happening. TRBR, tree branch. Tree branch is great because if you want to select a specific tree, let's say 0. Of course, in here there is no 0, so it will be bothered. Okay, 1, 2, 3. 1, 2, 3 will be perfect. 2, 3, 4, 5 will be perfect. But in this case, okay, let's say that I want to transfer these layers. This is 2, 3, 4, 5. I want to transfer them into 1, 2, 3, 4. This is really important because it will be easier to work with them in the future, in the next clusters. So I wanted to create 0, 1, 2, 3 instead of 2, 3, 4, 5. In this case, I created, okay, let's get this component which called tree statics. Tree statics give you the paths in the list. So as you can see, sorry, let me show you in a panel. These are the paths. In here you can see the length of each path. Maybe sometimes you need it, and here you can see how many paths you have. So okay, in this case I told it, okay, get those paths and renumber them. This is maintain, this is renumber. I right click and I say maintain path. I will check it. In this case I will check, okay, renumber the paths, and if I input this here, you can see that I've got the 4 layers, and they are 0, 1, 2, 3. This is really important. If you want to show something and you don't want it as an output, preview on. Okay, if I want to show a specific component, and you don't want to get inside the cluster, because sometimes it's really heavy to get inside the cluster, you can preview on the component that you want to show and preview off everything else. And for now, let's say save and close or discard. In this case, it doesn't matter. And of course I will preview, but there is something in here called preview content. Preview content, if I didn't preview it, because there is no output, it will preview me nothing. But if I said, okay, preview content, I can see what's happening inside. This is really important. This is useful. Let's say preview off. This is useful maybe sometimes in here. Where did I do it? Okay, we will see we will see it when you move on. Now I want to split my sub D surfaces that I have got. I want to split them based on their height, because let me show you what I want to do. Just for a quick, this is the actual envelope, that the original envelope of the Morpheus. I wanted to create this grid on the top part, this grid on the middle part, this grid right here is on this part, and this grid on this part. I only played with these 4, and there's one more, is the 5th. Okay, let me show you what's happening in here. In here it says, as you can see, it's in the middle, and this one at the ends. In this case, this is what I explained few earlier. This one is in the middle, this one is in the middle, this one is in the middle, but this one is like at the quarter. So that's important. This one is at the quarter, at the quarter from each side. So that's what we are going to do. First of all, let me go back in here. and let me show you these ones. Let me maybe go in here and go to, sorry, yes, select objects, yes, and I want to hide this. I don't need it now. Sorry, I don't need it to work right now. Yes, and maybe hiding this hi. Okay, and now let's, okay, because we don't need them to disturb us. Now this is the surface. This of course, as you can see here, it's an easy thing. It's just splitting them based on their height, nothing fancy. Just a split to get these ones, to get these ones, to get these ones, again to get these ones, and to get these ones, just to deal with every one of them as a several, let's say as a several grid reference. So nothing fancy is happening here. Now let's see what's happening in here. Let's preview on. Just to understand what's happening in here, I just created, let's say, these are some kind of grafted. I don't want them to be grafted. I simplified or trimmed the tree and sorted them along a specific curves. This is a component called center. If I clicked Control Alt and clicked on it, you can see that it's on the Heteroptera plugin. It's really useful to get the center. I don't want to use area because it's really heavy and it's calculating a lot of and it's creating a lot of unnecessary work and make the file heavier. You don't need to do that unless you really want to calculate the area of the surface. If you want to unless you want to calculate the area of the surface. Now this component is called point fits rectangle. It's kind of making a rectangle that fits all the points and sort the points around them. Why I wanted to do that? Because I wanted to use the indices of the point sorted and use it to sort the tree right here. So if I said, let's say list item right here, you can see that maybe we'll save. So okay, let me show. Let me select something smaller. Let's say 5. So if I moved on, you can see that they are not sorted. But when you select this one instead, you can see that this is 0, 1, 2, 3, 4, 5. You can see that they are sorted around this this rectangle. I wanted to work with them to get this part is to sort the curve based on the height of the z. Let's say I wanted to sort the curve on the z direction. Let's sort them on the z direction, and after all, this is what we've got so far. List item, again LIIT, to understand what's going on. This is the bottom curves, and Control C, Control V. This is the upper curves, and that's what I did to get those. Let's preview off. So now these are the surfaces that I want to deal with them. Preview off. Okay, preview off. And again, everything that I did previously, you showed, you have seen it already. This one is just creating 20 points, a range of 20 points. Remapped them, and that got me these curves. Let me show you what's happening in here. So that's that's the curves that I want to deal with them. Okay, I sorted them to, let me show you what's happening. List item. So these are just to sort them based on their z direction or something like that. Okay, these I showed these before. Also you can see, let's say list item, these are the vertical parts. I projected them and I want to sort them around the main rectangle. It's important to pick one rectangle to sort everything around it, because at the end you want to make sure that your curves are perfect. Let me show you what's happening in here. Just let me explain again what's happening in here. When you work with this, most of the curves, preview off and preview this off, some of the curves are going down, some of the curve are going up, some of the curve you know, it's a little bit weird. You don't want to do that. You want only the down part. Let me show you this the surface. So that's the surfaces. As you can see, it's not cool what's happening in here, so I had to sort them and pick only the lowest one, because I want these only. So that's what I had to do in here. Of course you need to make sure that the tree is perfect, because after all you will use it. So let me show you. I created a custom component called tree branch. If you clicked on it, it's basically getting a specific branch from the tree. Tamam. So if I said, let's say 50 or something, and I picked this one in here and I said zoom, you can see that this is the branch that I picked. Again, to understand, this is like a selecting an item, but of course it's a branch, not an item. You can see that there is a lot happening in here, but in this case I selected one branch to check what's going on. Zoom. Okay, and if I wanted to check multiple branches at the same time, because I wanted to do this again and again and again, I created another custom component called tree branch multiple. Okay, so in this case, let's say that I want to check the curves, I want to check the surfaces. Okay, and let's say I want a specific number. So if I said okay, zoom, you can see that the surface that I picked and the curves that I picked are matching. If they are not matching, that will create a difficult problem advanced. That's why you need to make sure that everything is data structured, because it will create a mess if it's built on a mess. Let me show you what's happening inside here. Again, this one is just to output the curves and the surfaces, but again I wanted these just to check several things with another colors. Sometimes you want to check that the first curve is related to the second curve, but it's really annoying, of course, when you have a lot of curves like this. Let me show you. Preview on. A lot of curves and a lot of surfaces, and you want to check, and there's a lot going on, and your eye will be like disturbed. So this is basically what's happening. Of course, there is a lot in here of data management and culling and things like that. Let me show you what's happening in here. Again, this was annoying because I wanted only to pick the top part like in here, and this is just to pick those parts. Okay, I sorted these. I told them, okay, make an average point of these. So as you can see, these are the average points, and I picked those only, the ones that they are above. Again, some sorting, some dispatching, culling, sorting around the curve, a lot of things like that. It's kind of a hard work, but the final result is really cool because as I showed before, each group of curves will be working with the same surface. So now let's of course I will say no for now, because if I said yes, it will take so much time to process again, which is not something I want to deal with. This one is easier. Actually, I showed this one before. As you can see, this is the curves, this is the surfaces, and this is what I wanted to do. The trick here, as I showed before, I wanted only to pick those, because in this case you will see preview on, and some of them are vertical, some of them are horizontal, and this is looking weird. And again, I wanted only to pick those, and those looking pretty fine. Okay, let me show you what's happening in here. In this case, again, I sorted the curves. I sorted the surfaces. I made them because they are already, if you seen them in here, they are already lofted, or maybe ruled surfaces. They are simple. You don't need at least two curves are linear. So I sorted them. I sorted the curves. I made, as you can see, I made a rolled or a lofted surfaces again, and I dispatched them. So these are the surfaces for the first pattern, and these are again, these are the surfaces for the second pattern. You can see that in here you have like from 2.5 to 0.5, from 0.5 to 0.75, from 0.75 to 1. There's a lot going on in here because I wanted to create this this part. It's in the 2.5, and you want to make everything looks perfect. Again, if you check the tree between these and the surfaces, it will be perfect. And let me show you what's happening in here, just to save us some time. I see that we are running out of time. Let me zoom. Okay, these ones are to make this part. And again, it's nothing almost fancy in here. This one is easy because you want, but it's not that easy because each surface got a certain curves. In this case, this one, and these curves will be, of course, nothing also fancy in here. It's kind of a data management. And again, when you see the final curves, you can see that these are the curves that we've got so far. These are the full grid that we want to work with it, and it's kind of let's say data structured, managed, and clean, and yet it's not so hard to work with it. As you can see, most of the clusters are 31 millisecond, 1.1 second. These are 1.7, 3 seconds, like stuff like that. And this is really important because you don't want to over process your file. Again, I want to separate the curves that I have done to a certain layers. These are the curves. If I said let's say tree branch, this component I showed you before, I will use it a lot to check the data. I said okay, let's say 5 or something, whatever it is, and zoom. Right click and zoom. You can see that it gives me weird curves. It gives me like a tree branch from the first layer, from all of the layers, and this is not really cool. So I created this this thing here which called path mapper. Let me show you what he will do. This is 0 1, and this is at 24 let's say at 24 item, and I wanted each item from each layer to be grouped together in a branch. So I told it okay, if I said path mapper, okay, and I connected to this, and I said create null. You can see that null is creating the data to be the same. The input will be the same as the output, but in this case I told it okay, I want the item to control the data. Let's say now I want the item. I will type I, and again I will type in here, I will type I, but instead of I will say okay, I want the item itself to control the data. So I will say okay, give me this to be I and give me this to be an A. Of course you don't want you don't need to capitalize everything. It will work so fine. So if I said okay, give me now the data tree, I will zoom and you can see, oh, that's all right. I want I've got exactly what I needed. The layers of curves will be you know, this is the layers of curves that I need. This is the shape of data structure that I need, and I will work with it. Again, I will try to move fast. This is the let me show you what's happening in here. This is the structure. This is the main curves, the glazing curves, and also the reference curves that everything will be oriented to it. And this is the cladding, that the layers of the cladding. Okay, let's move on. Now let me show you what I want to do. These are the curves of the structures, and I want to make them like this. So how can I cut them exactly where I know that they will not intersect? I want to cut them because I want to sweep them. Let me show you the final of them. This is preview. You can see here that the structure is not intersecting at any point, and the area between them are rationalized to fit a small node, a small structural node. So now let's see what happens in here. So let me show you what is going on here. Again, let's display plane, let's say 0.2 or something. Yes, that's perfect. Okay, so these are, let me show you, let's say TRPR, tree branch multiple, and I will check these with these, and I will say 5 for instance, and I will say zoom. You can see that this is the glazing layer. Let's hide this for a moment. You can see that this is the glazing layer that I want the structure to respect it, and this is the structure. This is the curve for the structure, and I want wherever I go, of course, I want the curves to be oriented to the structure, to the topology of the building, and that's why I had to make sure that the item indices are the controller of the data tree. That's exactly why I did it. So now let's say I will again, let's say what I did in here. Let me show you. Preview on. I wanted to divide these curves, but if instead of dividing them, I want to divide them based on their length, but instead of divide length, divide length, creating a weird place at the end, which I don't want. But in this case, okay, I said okay, let me show you what's happening in here. Each curve will be divided of course it will take only the integer as a division number, but of course each curve will be divided based on their length. I multiplied the length in this case by 3. Let me go in here and remove the expression. So this is the original divisions, but of course I multiplied them by 3 or 4 or something to get more points, but I don't want to make it really difficult. Okay, so this is what I want. Let me tell you something really important. If I wanted to create a plane, which is what I'm going to do in here, if I wanted to create a plane, there will be so many options that I want to create, that you can explore. In this case, I wanted to create a line. Why this is important? If I came from the top view and I created, let's say, yes, I created line in here. Okay, and I created line in here. Okay, and I said give me this curve, set 1. This is the first. Give me this curve, set 1. This is the curve. If I zoom to this, you can see that I created let me zoom to it from the perspective. Yes, you can see that I created a plane. The original, in this case, you can see the first line constraint will be the start point of the first line will be the original of the plane, and the line itself will be the x-axis or the u-axis of the plane. So in this case, I wanted to create a plane with these two curves. Why this important? Because if I came back here and said preview on and zoom, let me pick one data tree, let's say tree branch multiple, to see it better. Okay, and I said zoom. Sorry, I need to pick a number. Let's say 5, for instance. I'll say zoom, and you can see I created 2 lines at each point. Let me show it a little bit in here. Yes, I created 2 lines at each point, and this line, these 2 lines will be the plane or the orientation or respecting the original layer which we are dealing with. Let me show you what's happening in here. These are the points that are brought from the first layer to the second layer, and these are the lines that we created, that we wanted to orient our everything to it, and these are the planes that we wanted to create. Of course, when you create a plane like this is the planes, but of course I want the plane to be perpendicular, to be like a cross section. So I rotated it, as you can see here. I rotated it on around the curve. So if I hide this, preview off, and maybe we can hide this also, preview off, and show only one layer of it. And this is exactly what we've got so far. The planes are totally oriented to the original surface. If we show the original curves, that's exactly what we need. And this is what happens with all the curves around all the layers. This is really important. So now let's move on to the next part. Why these planes are important? Let me show you. This is a little bit heavy. As you can see, it will take 29, almost 30 seconds. So let me show if there is any questions. Yes, Ayman, Ayman Ismail. Yes, the video will be available on this channel. I hope everything is clear. If you are watching, let me know that everything is clear so far, and you are getting let's say a clear information. So now what's happening in here, let me show you, preview on. These are the curves that I wanted to cut. These are the planes that we've got from the previous cluster. I created point oriented. Point oriented are respecting the, let's say, are respecting the original planes. And from the point oriented, I created an kind of an offset. Preview on. And I wanted to create an offset because I wanted to get this point. As you can see, this point is really important because I want this point right here to be projected in the curve and cut the curve around it. That's the important thing for me. From this cluster, that's where I want to go. But let's preview off. In this case, I want each curve to be cutted at the beginning, at the end, and I want each curve to be treated separately, because after all, you don't want to grab all of the points at all of the curves at the same time. It will create a whole lot of mess. So in this case, I created these curves, okay, and I created these. Let me show you what's happening in here. This is a really important component. I will show you why. Let's say, let me show you. Okay, these are the curves that we've got so far. Let me hide it. I evaluated the curve. I evaluated those curves at the 0 parameter and at the 1 parameter, and I created something called line SDL. Line SDL is a great component, and it takes the start point and also the direction. Evaluate curve, give me the direction. So that's really important. Okay, Ivan, you say what's the reason behind using the line plane versus... let me show you why. Sorry, I will go back, discard and close. If I said brep, if I said, let's say, frames, let me show you one tree of these and one tree of these. If I said tree, branch, multiple, this is the branch, this is the other branch, and I will say, okay, let me bring me, let's say, for whatever, okay, and bring this one here and zoom and hide everything else. Preview off. Let me show this. Preview on. And let me show you the curves. Preview on. Sorry, let's zoom in here. Yes. If you can see right in if you can see in here, the blue ones are the ones that we've did, and they are totally oriented to the surface, but the beard curve is not oriented to the surface at most of the time. That's why I used it. I tried it, but it didn't work. That's why I created my own planes to make everything oriented to the surface. That's you need to do this to make a structure simple enough to be to mostly at least two surfaces are planar, and the other two are ruled, at least most of the time, of course. This is why I did it. Now discard and close. Let's move on to this one. Again, as I mentioned, the some of the clusters are heavy because there are so much happening inside, and you need to in this case I needed it to be this way, so let me show you why. In this case, every curve is grafted, so if I said Control C, Control V, and I didn't graph this, so each curve will contain 2 points, and I will measure the distance at those 2 points and the distance at all of the curves. These are the curves that we wanted to measure. Preview on. Yes, and I took the start point of these curves because, after all, when I created them, I made the point is the start point, and I wanted to pick it back, but I wanted to pick it from the curve itself because I want to use those to curve them based on a specific type of data structure. So these are so heavy. That's why this component is a little bit annoying. But to show you what's going on, let's preview. Let's zoom, sorry, to this. To understand what's going on, each curve will get the points that are close to it based on a certain distance. In this case, I said, okay, bring me the points that are less than 1.7 and put them in a separate group or in a separate branch. So now when I say, if I change this, for instance, now, and set zoom again, wherever I go, I will find my data are so perfect. These are the curves that I want to deal with them. This is the curve that I want to cut, and this is exactly what I want. This is perfect. So that's what's happening in here. Again, let's move on. To understand what's happening in here, let me show you. These are the curves that we cutted, but how we can cut it, let me show you. First of all, these are the curves that we've got, the SDL curves. I extended them a little bit just to make sure that everything is working perfectly, because I wanted to sort them. I don't want any of them to be intersected. You don't need this step sometimes, but just to make sure everything will be perfect. Okay, and I sorted them. Let me show you a specific tree, TRPR again, and let's say zoom. So this is the tree that we will, let me hide these, preview off, And let me hide these also, preview off. This is the tree that we will dealing with. Zoom. Okay, and let's say list item. I will say 5 for instance. Okay, and now from 0, this is the 0, 1, 2. As you can see in here, they are not sorted the way I wanted them to be sorted. That's why I sorted them around a circle. The circle is based on their endpoints. So that's what's happening. So if I said, okay, bring me this, and now if I said 0 1 0 1 2 3 4 5 6, you can see that they are totally perfect, totally sorted, and that's what's happening in here. Okay, again, I wanted to pick, let me show you, and show you in the front, and zoom. Okay, to understand what's happening, I want to pick those with those with those. I don't want it after I sorted it. I don't want it to pick those parallel, because I want it to solve the intersection between non-parallel curves or lines, and in this case I made a little bit of trick. And to understand what's going on, let me show you. If I pick this one, let me put it in here. Yes, you can see that some of them are parallel. If I moved on, as you can see, some of them are parallel. So that's not a great way to solve the intersection, because they will not be intersected. I did a little bit of trick here, based on the angle between the first and the second item of the list. I said, okay, if the first item and the second item, the angle between them is less than 15. Why I did it 15? Because they are not planar, on a planar surface, so you need a little bit of flexibility. So I told it, okay, if the angles are not 15, move on to shift it. If it's 15, keep it. If it's less, keep it. So that's what's happening in here. Let me show you. So when I input this one, you can see that all of the curves from everywhere are not parallel. That was really important, because I wanted to grab these points based on curve proximity. Curve proximity is solving the intersection between the curves, even if they are not intersecting actually. Let me show you in the perspective, and let me show you, for instance, let me show you a tree branch. Let me pick this one and say TRPR, zoom. You can see that this curve is not intersecting with this curve, but it will somehow measure the distance between them, and make these points at the minimum distance, at the smallest line in this case. So this is what's happening in here. Again, I want to cut the curve. Let me show you, preview on and zoom. Again, this curve will be cut by these points and these points, because I trimmed them. And of course you don't need more points in your script, so because it will take so much time to process. And I shuttered them, and in this case I told it, okay, sort them by their length, but I need the largest one, because it will create so many shattering in here and so many shattering in here, but I need only the biggest one. I don't need the other ones. So preview off, and as you can see, these are the curves. And let's move on. There is a lot of things in here. These are just to dispatch some of the curves, because some of them were a little bit annoying, and these are the final curves after cutting. So that's basically the cutting part. Let's move on to the structure, the exoskeleton. These are the curves. Let me hide this for a moment. These are the curves. Again, I did a planes to work with them, but the planes is as the start only, the start, and I rotated them around the axis. The axis is this part, is this curve, which I used it to create the plane at the first place, and I created let's say the section for the structure. In this case, I created a simple section, and again I just rotated it 45 degrees because I wanted to be exactly pointed to the structure, sorry, to the main surface. And of course the sweep thing after that, and this is exactly the structure. You can see it's perfect, it's not intersecting. Some of the curves are twisted a little bit. They are not 100% linear, such as this one. Of course, in Zaha Hadid architects or Bro Hubbled, when they did the structure, they had a lot of cases to deal with them parametrically and stuff like that. But as an example, as an exercise, as a practice, I did it this way. And of course I'm not a structural engineer, but you know, it's important to understand what's going on behind the scenes. Let's move on. Now I wanted to create let me hide this. I wanted to create, this is the curves. I want to move on to create let me show you. And let me show you this. I wanted to create these nodes, these structural nodes, and I wanted to create them exactly at this point, and I wanted to create them parametrically. So let me hide these, preview off, and show you what we will have. Again, this is you already shown before. It's just basically creating a planes at the end, at the start and at the end of every curve. I need to move fast a little bit. Okay, let me see what's happening in here. This is just to understand what's going on inside each sphere. These spheres are just to visualize what's going on. It's not related. Just to understand, okay, I want this distance to be, I want everything to fit, I want to measure the distance between each point, which is these points, and the other points in the grid, and I want to understand the that I want to visualize the distance. So I made a mesh sphere. You don't want to make a beer sphere, because it's really annoying to process. Mesh sphere is fine in this case, and this is just to make it a little bit transparent. This is a great component called create material to make it a little bit transparent. Now let's move on. This is just to big groups to make everything like this. Again, let's move on to the next part. This is just to understand what's going on. Let me show you. These are the main curves. Let's say TR, PR, I will pick one of the zoom to see what's happening. This is one of the groups that we are dealing with. Of course, we sorted them around the curves, around the circle. This is something called circle fit. It's really important because you want to sort the points of your the start and the end points of your curves around the let's say around the circle, because you want to use them to make a polyline from them. So after sorting them, you created a polyline, and I used the surface the circle, sorry, to I used the circle, as you can see here. I used it to project the polyline on it, because the polyline was not planar. As you can see, it's a little bit looking weird, so that's not what I wanted. I projected, and this is just to let me show you. This is just to pick the complex nodes. Let me zoom a little bit, zoom in here. These were the large nodes that I want to work with them more, and these are the full nodes. These and these were I wanted to work with them more because they are so huge and so weird. But everything else looks pretty fine for me, so I moved on to the next part. So this is the nodes. Of course, the symbol nodes I created as I created the surface right here. I created the surface right here. I moved, of course, from the evaluation of the main, let's say, surface, the polyline, and I created the ruled surface around it, around this one and this one. So that's pretty much it. But let me show you what's happening in here. Preview on and zoom. Those I had to split them into like a more complex node. So this is the original shape, and I let's say I picked only the largest two curves, and I made like an offset for every one of them. Preview off, and I created these points. Preview on, and I made a line. Preview off. Of course, I created let me show you in here. This is the first curve, this is the second curve, this is the other curves. Preview off, and this is the surface of the node, but I wanted to split it, so that's exactly what I did. I picked let's say, yes, I picked these lines, and I split the curve. So now I have those surfaces. Preview off, of course, preview off everything, and now this is the final node. As you can see, this one is more complex than the other ones, and this is working pretty fine. Discard and close. I don't have much time to go further, but I will show you a little bit what I did with the fabrication. Of course, the cladding is much more let me show you. The cladding is much more complex. Maybe I can show you this one here. Yes, this with this. Preview on. This will take a little bit of time. Sorry, I want this, not this. Preview off. Yes, this is the cladding. It's much more sophisticated, and almost look like the actual cladding from Zaha Hadid. Of course, they are perfect at what they are doing, but this is just my version of the envelope. The glazing also, if I said let's say preview on this and this, you can see that I picked the simple surfaces. I made them just simple glazing, and even the ruled one, the curved one, I did it in a simple way, but the middle one I created in a triangulated way. Okay, and now let's preview this off for now. Let's move on to this part. This part is really important because let's zoom a little bit. I wanted to pick a specific curve or a specific member and check the intersection between the member. Let's say not the intersection. I want to check the distance, the minimum distance, the proximity between the intersect between the curve, between the structure and the cladding. This is really important. As you can see, you can pick whatever you want, which item you want. Let's say I picked this one, I zoomed, it's totally parametric, and I want to check, for instance, at this point, at that point, whatever it is. And if I said okay, preview on, zoom, you can see that this is the intersection at specific point. Again, if I moved on, you can see that this is moving along with it, and this is kind of a really great one. Let's preview this off. The cladding, I wanted to fabricate the cladding because they were really kind of a hard thing to fabricate. Let's say preview on, and let's say zoom. I picked this one. You can see the full envelope right here. I picked this one, for instance. Okay, and I said okay, I want to fabricate this one. So this one, if I said okay, zoom, you can see. Let me again. I picked this one. I deconstructed it. I take it. I give it a parametric coding. Let's say for fun, I will change the number here. Let's say 50 or something. You can see that it will generate a parametric sheets, a parametric. Everything will be parametric, and as you can see, also the sheets will be fabricated like this, and each one will take its own code to understand and also to see what is happening. Let me go in here, for instance, and if I said TRPR tree branch multiple, let's say, or maybe list item. Let's say list item. Okay, and I want this one. Actually, I did it in here. Yes, I don't need to create it again. Preview on. As you can see, this one is 51R, and this one is 51R. If I moved on to the next one, to the third one, to whatever it is, I can pick the right one and unroll it exactly on the surface. This is with its own, let's say with its own code and everything. Of course, I don't have much time now to explain everything, but I will show you just what's happening in here. Sorry, not this. Yes, show me this one. Preview. Let's preview off these now. Preview off. Zoom. Yes, these are the cladding. Let me show you. Preview on. This is a little bit heavy. Yes, I will pick only this one, and I want to fabricate it, so I will say okay, preview on, and show me what's happening. Preview on. These are the fabrications of it. Now if you see, this is the original node, and you can see that these these two surfaces are not planar, so I had to make these molds to fabricate them, but these surfaces are ruled surfaces, so it will be easier to fabricate them. So these are the surfaces for the ruled parts, and these are the complex surfaces right here to be fabricated. Of course, I can go and move on to solve the intersection between them, and to give exactly what I need for each surface. But for this example, just just a basic fabrication information. These are the two surfaces, and as you can see, each piece is decoded parametrically. If I changed this one maybe to 100, for example, or something, and you will see that this will change according to, if I said, let's say 33 or something, I created, let's say 300. It's really important to understand what's going on, because if your script is not working 100% perfectly, you can see that you will see a lot of errors. In this case, this is the one of the flattened one. These are not patched. But so if they are not patched, I don't need to create the mold to fabricate them on it. And so in this case, I told it, okay, if it's not if it doesn't need a mold, just cut it on a surface, and we will be assemble it again. So that's mostly it. Thanks everyone. I really hope you enjoyed this talk. I wish if there is a lot more time to share more information, but of course I'm running out of time. Actually, I passed the 2 hours limit. Again, thanks everyone. Of course, if you need more information, if you want, if you are interested, I will make a workshop to build this envelope from scratch. If you are interested, let me know about it. And I hope everything was clear. If you have questions, let me see. I'm very much curious because it's encounter similar symbol. Okay, Ivan, thanks. How were you able to solve the difference fillets and chamfers of each intersection of a non-planar curves? I don't know if you are talking about the cladding or what. Let me know. If you are talking about the cladding, it's not a fillet, it's an illusion of a fillet. Of course, I don't have much time to show it, but it's kind of it's really an interesting component called by arc, which is creating an illusion of a curve. It's not a fillet, it's a curve based on a specific directions, and that's it. Thank you everyone, and I hope to see you soon. Just for a conclusion, there is a lot of information in the important link in the description. They are really important to understand the envelope, to understand a lot of parametricism, tectonism, a lot of things like that, which they are important to computational designers. Also, the social media for Exact and for me are down there. Thank you everyone, and the video will be available. So also let me know about the workshop thing, and thank you everyone. Have a nice day.